Create a new notebook.
Click the Design Editor button. Select the rectangle tool, double-click to edit its text.
Teaching machines to read our drawings. Can they?
Add a new cell.
Open the Data Science tab and drag in a dataset block. Which dataset should be used this time? Navigate to the app's dataset folder. There's the QuickDraw dataset. It's a What's in the Drawing classifier with 5 categories. QuickDraw is a massive collection of simple sketches drawn by people worldwide. Each doodle is tagged with what the person intended to draw, making it a perfect challenge for teaching machines to recognize drawings. Back to the dataset page. At the top left, you'll see a summary illustration. On the right, we show the dataset's input structure along with its classes. Below that is the full dataset table where each column header includes a mini histogram of that feature. And if you hover over the Labels column, you'll get an enlarged view of the drawings. Rename the dataset to QuickDraw. Add a splitter block and set the test size to 0.3. Then add a classifier block and switch its type to SVC. To create a method, just click the +M pill button. Call its getScore method to measure accuracy. Click the left icon to turn the method into an output block, adding an output handle you can feed into other blocks. Push that getScore block inside a print block to see the output. View the generated Python code to check how it looks. The code viewer updates in real time, generating Python code from your blocks as you edit them. Run the cell. Oh, we got an error. We still need to define the classifier variable. Click the classifier's left icon to create its identifier, myClassifier, so we can reference it later. Nice, we got a classification score. Let's create another cell for predictions. Once again, select the QuickDraw dataset. Add a take block. Set type to random and rows to 5. Then add a table view block and run it to preview samples. The table view shows the 5 rows pulled in by the take block, and the 10-column limit neatly trims out the middle columns. Back to the first cell. Create a classifier method block and change it to predict. Cut and paste it into the second cell. Wrap it in a print block and run. Compare the predicted labels with the dataset's true labels. With nearly 80% accuracy, we got only 1 error out of 5 sample. Now add an accuracy plot from the visualization category. And there it is, an awesome classification accuracy plot. At the top, it displays the confusion matrix with a single mistake. The true label, cat, was misclassified as mermaid. Below you can see the per-class metrics bar chart, and on the right, a summary of the overall performance metrics. Even better, we can actually draw something ourselves and let our model guess what it is. Let's add a new cell. Now, copy the prediction line together with the print command and paste them into this new cell. From the Datasets category, drag in a drawing input block. Notice its size is already set to exactly what we need, 28 by 28 pixels. The drop-down contains various pixel size options. Click the white square and make your drawing. When you're done, click OK to confirm. Run the cell, and the model correctly predicts cat.